In this video, dear learners, we will see the analysis of motion of a set of connected bodies. Motion of connected bodies. There will be more than one body which is connected by a string or something else. In this present case, we will consider bodies connected by a string. Okay, so we will be directly we'll go to a problem so that you will understand the concept easily. So in this problem, two blocks A and B of weight 80 Newton and 60 Newton are connected by a string passing through a smooth pulley. Passing through a smooth pulley as shown in figure. Calculate the acceleration of the body and the tension in the string. So find out acceleration and tension in the string. So these are the two quantities we have to calculate. The given figure is like this. This is 80 Newton. This is 60 Newton. And it is supported on a pulley using a string. So this is the question. Okay. So as usual, if a number of bodies are involved in motion or simultaneously a number of bodies are moving, and especially when they're connected also, we have to consider each body separately, draw free body diagram of each of them, then apply the corresponding equations, then we will solve it to find the required quantities. So in this case also, two blocks are there, block A and block B. They are connected by a string through a smooth pulley. A smooth pulley means there will not be any friction or there will not be any force on this string. So if there is friction or if the pulley is not smooth or if it is having some weight, then the movement of this body will be different than on a smooth pulley. Okay. So in this case, as the pulley is smooth, this will be just like this, say B and A. Okay, applying a force in this direction, a force in this direction, that is, this is 60 and this is 80. Newton. 80 Newton force is acting in this direction, 60 Newton in this direction. That is, the pulley is just doing a direction change. That's all. Okay, what I mean is, say in this case, there will be tension in the string on both sides of the pulley. രണ്ട് സൈഡിലും tension ഉണ്ടാവും. And as the pulley is smooth, this will be T, this will be T, because in this case, tension will be same throughout, T. Wherever we take the tension, the value will be T, same. So here also, T will be same. Okay. That is one point we have to keep in mind. Another thing is, just by looking on the figures, we can see 80 Newton block will be moving down. isn't it? 80 Newton block will be moving down, say with an acceleration of a. Okay, so B will be moving upwards with the same acceleration, isn't it? B will be moving upwards with the same acceleration, because if 80 Newton moves through say 50 centimeter in t seconds, the same time B will move up through 50 centimeter. That means acceleration will be same. Okay, so tension on both sides of both portions of the string is same, that is assumed as t in this problem, and acceleration is same for both the blocks, and it is assumed as the magnitude is a. The direction of acceleration for block A is downwards, and therefore B is upwards. Okay, so with this information we can start solving the problem. Okay, so that is A. Now let us consider block A, that is 80 Newton. Then draw the free body diagram. This will be 80 and this will be tension. Okay, only two forces are acting on this body, 80 Newton weight acting downwards and a tension in the upward direction. Okay, then it is moving with acceleration of A downwards, isn't it? Then for block A, we can apply Newton's second law of motion. So what is Newton's second law of motion say? Saying it says that the net force acting on a body is equal to mass times acceleration. Therefore, here in the vertical direction, sigma F equal to ma. Okay, where ma into a, acceleration is same for both. So this will give you what is sigma F? Net force in the vertical direction. It is moving in downwards, so it is the force is down in the downward direction is taken as positive. So 80 minus t equal to ma is 80 by 9.81 into a. Okay, so that will give you 80 minus t equal to 80 by 9.81 into a. Let it be equation number 1. Okay, now consider block B. Okay, considering block B, we will draw the free body diagram for that also. This is 60 Newton, same tension T acting upwards, and it is moving upwards with acceleration A. Okay, now apply Newton's second law. Sigma F equal to mb into A. A is same. That will give you 80 minus T, sorry, 60 is in the opposite direction. So T is in the same direction of motion. So T minus 60 equal to mb, that is 60 divided by 9.81 into A. Okay, so this is equation number 2. That is equation number 2. Now we have two equations. with the T and A as unknowns. T and A as unknowns. Now to solve this, what to do? 1 plus 2 will give, what you will get? That is, I will write it again. 80 minus T equal to 80 by 9.81 into A, and minus 60 plus T equal to 60 by 9.81 into A. Adding these two will give 20 equal to 140 into A divided by 9.81. That will give you A equal to 1.4 meter per second square. 1.4 meter per second square is the acceleration of the body. Once you get acceleration, by simply substituting the value in any of the equations we have formed, we will get the tension, because tension is same for both the cases. For tension, what we can do is simply substitute the value of A in any of the equation, and the tension T you will get 68.5 Newton. By substituting the value in any of the equations, you will get tension equal to 68.5 Newton. Okay, so in this problem of motion of connected bodies, we considered the body separately and formed the equation by drawing free body diagrams of each of them individually. Okay.